Hello and welcome to my channel. Today we are going to learn what Surds really is, and I'm going to introduce you to some basic information of a rational and irrational number. But let us first look at what Surd really is. So we've got a definition here. A number whose exact roots cannot be found is called a surd, and there are special type of irrational numbers. So the number whose exact root cannot be found. If we take a look at one example, say if we if we try to find the root of 4, what we get is 4 is 2 squared, so this squared and root get cancelled, so it is 2. So we can say that 4 has its exact value. The root of 4 has exact value, which is 2, so it is not a surd. So we can say root 4 is not a surd. So if we try to find the root of 3, we get something like 1.7320507, and the pattern continues. So since we know that we cannot determine the exact value of a root 3, so it is surd according to our definition, a number whose exact root cannot be found. So exact root of 3 cannot be found, so root 3 is a surd. And we've also been informed that there are special type of irrational numbers. So we can say that root 3 is a special type of irrational number. But what really is irrational number? So let us look at this. As we've determined that root 3 is surd, but let us try to look for the reason why root 3 is irrational number. So irrational number means it is just the opposite of a rational number. So when we just look at this term over here, there is the familiar term which is ratio. I hope you know what ratio means. We can also say the ratio to be fraction of some sort. So ratio is the fraction. And irrational number are those numbers which cannot be expressed in the form of p by q or in the form of a fraction. But if we look at the rational number are those numbers which can be expressed in the form of p by q, where p and q are integer prime to each other, or we can say p and q are the whole number which are different from each other. Some examples of rational number are 13, -5, 9, 0, 2 by 3, 0.5. So let us look why 13 is called a rational number, as we can express 13 in the form of 13 divided by 1. So here 13 is a whole number and 1 is also a whole number, and as we can express 13 in the form of the fraction 13 by 1, it is called the rational number, or the number which can be expressed in the form of a ratio. Similarly, 0.5 is also a rational number, because when we divide 1 by 2, or we take the ratio of 1 to 2, we get 0.5. So since 0.5 can be expressed in the form of ratio or in the form of fraction, it is called the rational number. Similarly, 2 by 3 is already expressed in the form of fraction, where 2 and 3 are different numbers, so of course 2 by 3 is a rational number. Now let us look at some properties of rational number. When changed to decimal, when these rational number are changed to decimal or changed in the form of decimal, they are either non-terminating recurring decimals. It means the decimal or the number after the decimal does not end, and recurring means the pattern repeats after a certain interval. Or it can also be the terminating decimal, like we've taken the example of 0 0.5 right over here. So this is the example of terminating decimal. But if we look at the rational number 2 divided by 3, although it is the rational number, when 2 is divided by 3, we get the answer 0.6666666 and so on. So this is the example of recurring or repeating. So this pattern never ends, it continues till infinity. So we can say that 2 by 3 is a rational number, as the decimal is non-terminating, means it never ends, and recurring means the pattern 6 has repeated after uh, another 6. So um, as it satisfies the property of rational number, 2 by 3 is called a rational number. So the properties of rational number are: when the rational number or the ratio p by q is converted into the decimal, the decimal are either terminating decimal, like 1 by 2 when converted into decimal is 0 0.5. So there is no repetition of pattern, and the decimal also stops after 5. So after 5 there is no other number. Or when the rational numbers are converted into decimal, the decimals are non-terminating but recurring. It means the pattern continues after a certain interval. Here 6 is repeated after another 6, and this pattern continues till infinity. So when these two properties, either the first property or the second property is satisfied by the number, we can say that the number is a rational number. But in case of irrational number, we cannot express this number in the form of ratio. Like for this root 3, which value is 1.7320507, we cannot find the fraction which gives the same value that is given by root 3. So there is no number, there is no any fraction that gives the value as given by root 3. So we can say that the irrational number cannot be expressed in the form of fraction. Also, some popular example of irrational number is pi, simply written as pi, which actual value is 3.1415926535897932328, and the pattern continues till infinity. So the decimal is non-terminating, and if we look at the pattern, then we can see that there is no any number that repeats after a certain interval. All the numbers are different from its neighboring number 141592. There is no any recurring number in this decimal. So non-terminating and non-recurring is the property of irrational number. I've written here, when the irrational number are changed into decimal, they are non-terminating, as we've already seen here, and non-recurring. Decimals, the number or the pattern doesn't repeat, like we've seen in the rational number. For 2 by 3, here the pattern has repeated after a certain interval, but for pi, this doesn't hold true. And there is no any fractional number that gives the exact same value as the pi. We cannot represent pi in the form of any fraction or the ratio, so it is irrational number. Also, root 5 is the irrational number because we cannot express in the form of ratio. There are more examples of irrational numbers like Euler's number, the golden ratio, and so on, but we're not going to deal with more examples here. Now let's look at some properties of irrational number. When we multiply two irrational numbers, say pi, we get pi squared, which is once again irrational number because it cannot be expressed in the ratio. But if we take a look at another irrational number, which is root 2, when we multiply root 2 with itself, we get 2 because uh, you know uh, why we get 2. And yes, 2 is a rational number because it can be expressed in the form of ratio, that is 2 by 1. We've got two different whole number, 2 and 1. And yes, since it can be expressed in the ratio, it is rational number. And one more thing I want you to remember is between the number line 0 and 1, we've got infinite number of irrational numbers, because when dealing with the number line after 0, we have 0.0000000, and at last there might be 1. Similarly, the number after that is 0.0000010111101, something like that. There are infinitely many numbers between 0 and 1 which are of non-recurring pattern, and if the decimals are non-recurring and non-terminating type, then of course it is irrational number. So we can find infinite numbers which are non-recurring and non-terminating type between 0 and 1. So of course we can say there are infinite numbers of irrational numbers between 0 and 1. So I hope you got the idea why the sort is called the special type of irrational number, because if we take a look at root 3, then when looking at its decimal pattern, we can say it is non-recurring and non-terminating type, and also root 3 cannot be expressed in some ratio, so it is irrational number. And surds, once again I'm going to repeat, is any number whose exact root cannot be found. So as we cannot find the exact root for root 3, 2, 5, so all these numbers are surds. So I hope you got the concept for surds, rational and irrational number. I hope you liked the video, and yes, thanks for watching, and please do subscribe for similar updates. Thank you.